All right, only 4 slides that we've got to go through in these examples. Really fun. Find the limit as x goes to 0 of x over the square root of x plus 1 minus 1. This equal to, I'm just sort of telling you what it is. Shh. The first thing we're supposed to do is substitute this 0 in, because if I get an integer value, cool, that's the limit. And I don't mean an integer, I just mean any real number. If I get a real number value, cool, that's the limit. Here I get 0 over 0 plus 1 is 1, square root of 1 is 1, minus 1 is 0. So this is undefined. And throughout the rest of the chapter, we're going to talk about, like, how do I come up with these undefines and deal with them. But right now, we're just going to look at this graphically or in a table. If I were to be filling out this table, at 1, I would have at 0.1, I would have 2.05. Here I would have 2.005. Here I would have 2.0005. Here I have, once again, undefined. Here I would have I think that's 1.9995. Here I would have 1.995. And here I would have 1.95. So you can see sort of in this table, then we'll get to the graph. We can see in this table I'm going 1.95 and I'm increasing and increasing and increasing. And then I hit undefined. And then I just sort of jumped right over 2 and went to something super close to 2. So from the right and from the left, I'm getting arbitrarily smaller and smaller and smaller and closer to 2. Graphically, you can also see this. Remember that in a graph, you're not going to see that there's a hole. But if you tried to evaluate this at 0, you would end up getting a hole in the graph here. But you can see from the graph, from the left, I go to the y value of 2. From the right, I go to the y value of 2. So that is what the limit is equal to. So the limit as x goes to 0 of f of x is equal to 2. Okay, moving along. Find the limit as x goes to 0 of absolute value x over x. So this is what our absolute value x over x function looks like. It's -1 always to the left of 0 and +1 always to the right of 0. So if I want to evaluate this limit, first I substitute this in. I get 0 over 0. So then I'm like, that didn't help. But if I look at this graph, from the left, the y value that I am approaching is -1. From the right, the y value that I am approaching is +1. That tells me that the limit does not exist. And again, I know that because I am approaching different limits from the left and right. Okay, so now we're just going to go through a whole bunch of different relatively quick examples. All of these I'm substituting in first. So I get e to the 0 minus 1 over 0. Anything to the 0 power is 1. 1 minus 1 is 0 over 0. So this is undefined. Now, I don't want to leave undefined as an answer. I want to, maybe look at what does this graph look like. So what I did is I went to my graphing calculator and I graphed this function. And I saw this. This is a light little sketch. And when I was at 0, so the limit as x goes to 0, there was a hole in this graph. But from the right and from the left, okay, yeah, that's sort of the left. The value that I was approaching was 1. So the limit as x goes to 0 of e to the x minus 1 over x is equal to 1. And I can see that graphically. Here, substitute in my 0. So I'd get the sine of pi times 0, which is the sine of 0. And the sine of 0 is 0. Now this is not undefined. This is just telling me the limit of this as I go to 0 is 0. Final answer. Substituting in, I get 7 over 3 minus 3, which is 7 over 0. 7 over 0 is still undefined. Now, Later on in the chapter, we'll talk about how these undefineds are different, because this one's a little bit more unique. But graphically, if I were to graph this is going to look like a function that has an asymptote at x equals 3, and otherwise looks like this. So if I'm talking about an overall limit as I go to 3, from the left, I'm going to negative infinity. From the right, I'm going to positive infinity. So this doesn't meet either criteria in those first two cases. This is unbounded. It's rising or falling infinitely, and it has a different rise and fall from left and right. So here, your answer is not undefined. It's that the limit as x goes to 3 of 7 over x minus 3 does not exist. Not undefined, does not exist. Here, I'm substituting 2 in, so I get 2 times 2 squared minus 4 times 2 plus 6. 2 squared is 4 times 2 is 8 minus 8 plus 6, so I get 6. Again, no issue there. I was able to substitute that in. That is my limit. Here, if I substitute in, I get negative 10 over the square root of negative 2 plus 2, which is negative 10 over 0. And again, in this case, I get undefined. So I'm going to look at this graphically. I graphed this in my calculator, and what I saw was a function that looked like this. It's a little bit of a weird function. So what was happening with this function is that it is sort of like a square root function. And the issue that we have here is from the right, this approaches, I don't know, some value, but there is no left of this function. Because there's a domain restriction here, this function only exists from negative 2 to infinity, not including negative 2, because that would give me 0 in the denominator. So that means this function exists to the right of negative 2, but it does not exist to the left of negative 2. Therefore, it cannot meet the condition of having the same limit from the right as it does from the left, because it doesn't have a left. So the overall limit here does not exist. And again, that's because the limit from the left doesn't exist. So the limit from the right and the left can't be equal. Here, my limit does not exist. And the reason is because the graph's unbounded and you don't go to the same value. Here, I get undefined, but I still have a limit. All right, and then a little bit more. If the limit of x goes to c of f of x is equal to 4. So I'm telling you the limit as I go to some value c of the f function is 4. The limit as x goes to c of the g function is negative 2. So the limit as x goes to c of negative 2 times g of x. Again, that negative 2 sort of comes out, and it's negative 2 times the limit as x goes to c of g of x, which is negative 2. The limit of x, or the limit as x goes to c of g of x, we know is negative 2. So I have negative 2 times negative 2, which is 4. The limit of the difference of these, remember that can, it almost looks like it's being distributed, when really all you're doing is saying, well, I can take the limits separately of each of these functions. The limit of f of x is 4. The limit of g of x is negative 2. So I get 6. The limit of g of x times f of x squared. So g of x is negative 2. F of x is 4. And I'm able to just square the limit of that. So I'm going to have negative 8 squared, which is 64. So whatever those functions are, if I were to multiply them and square them, I know that as I go to c, whatever c was, I would be going towards the y value 64. Here it looks a little bit harder than it is, but that 3/5, really that can just come out. Those are separate multipliers. Or you can just apply the limit to each one separately. So the limit of f of x is 4, so I'll have 3 times 4, over the limit of g of x is -2, so 5 times -2. That gives me 12 over -10, which is -6/5. So not too bad, just a little bit weird. You're applying those properties in different ways, but keep in mind that when you see that limit of g of x times or plus or times some integer value or divided by a different function, you can apply that limit to each function separately. All right, that's it for the examples. Get started on some of that bookwork, very exciting chapter, a lot of graphical things, so you're definitely going to want to have a calculator with you.